Hello and welcome to this session. NOR gates, like NAND gates, are universal, capable of recreating any logic function. NOR gates exhibit properties that allow us to construct the fundamental building blocks of digital logic, the NOT, AND, and OR gates. We can build these basic gates step by step by using NOR components. This is possible because NOR gates can invert and include the OR function.
Objectives. At the end of this session, you will be able to construct AND, OR and NOT gates using NOR gate, and realize and verify the truth tables of AND, OR and NOT gates using NOR gate along with switches and LEDs. Let us first recap the concept of NOR gate. You have already learned that NOR means OR plus NOT. That means the OR output is inverted. Therefore, the NOR gate is a combination of OR gate and a NOT gate. A NOR gate is a type of logic gate whose output is high only when all its inputs are low, and it gives an output low even if any of its inputs become high. Therefore, the operation of the NOR gate is opposite to that of the OR gate. Next, we will construct AND, OR and NOT gates using NOR gate. For this, we will need the following tools and equipment. Regulated DC power supply 0 to 30 volt and 3 ampere, 1 number. Digital multimeter with probes, 1 number. Wire stripper, 1 number. Nose plier, 1 number. We will need the following materials and components. Breadboard, 1 number. IC 7402, 1 number. Miniature toggle switches, 2 numbers. Hookup wire as required. Resistor 330 ohm, 1/4 watt and CR25, 1 number. And LED 5 mm, 1 number. Let's now dive into the procedure of construction and testing of AND gate using the NOR gate IC 7402 and verification of its truth table. Before proceeding to the hands-on procedure, let us look at the logical circuit. Connect input A to a NOR gate. Connect input B to a separate NOR gate. Connect the outputs of those two NOR gates to inputs of a third NOR gate. The output of this third NOR gate will function as an AND gate. The first two NOR gates invert the signals, and the third NOR essentially ANDs the inverted signals by going high only when both inputs are low. This constructs the logical AND function. Let us now look at the procedure. Once ready, collect all the required components. Check them. Ensure the resistor and LED are in working condition using a multimeter. Once you have got everything, mount the 14-pin IC firmly on the breadboard. You can also refer to the circuit diagram for accuracy. Safety tip: handle the IC with care to avoid bending the pins as you insert it into the breadboard. Connect linking wires from the power supply to the breadboard. Next, connect 14th pin of the IC to the plus 5 volt power supply. Then make sure pin number 7 is connected with ground. Connect both terminals of the toggle switches to the power source and ground. Connect your toggle switch S1 to both pin numbers 2 and 3. And S2 to both pin numbers 5 and 6. The first pin of the NOR gate is connected to the 9th pin, and the 4th pin is connected to the 8th pin of the IC. The output is obtained from the 10th pin of IC. Now let's set up the visual indicator. Connect a resistor to the output pin number 10 of the IC. This will limit the current to the LED protecting it from burning out. Then attach the anode of the LED to the free end of the resistor and cathode to the ground. This will help us to see the result of our AND gate's output clearly. Before you power up, get your assembled gate circuit checked. This is crucial to avoid any short circuits or incorrect connections that could damage the IC or affect the functionality of the circuit. With everything checked, switch on the 5-volt DC supply. Begin the test by operating switches S1 and S2. Check if the toggle switches S1 and S2 are in the low state. This indicates 0-0 combination. For this, let us verify the LED. It is not glowing. Now toggle the switches to 0-1 combination. Verify the LED. It is still not glowing. So we know that if any of the input is 0, AND gate produces the output 0. Now toggle the switches to 1-0 combination. There is no change in the output state. LED is not glowing. Finally, toggle the switches to 1-1 combination. You may observe now that at the output LED is glowing. The next procedure is the construction and testing of OR gate using NOR gate IC 7402 and verification of its truth table. Before proceeding to the hands-on procedure, let's look at the logical circuit. Feed inputs A and B into a NOR gate. Connect the output of the first NOR gate to input of a second NOR gate. Output from second NOR gate will function as OR. So the first NOR gate combined with the second NOR gate inverts the function twice using the NOR properties, resulting in an OR overall. Let us now look at the procedure. Collect all the required components and check them to ensure the resistor and LED are in working condition using a multimeter. Once you have got everything, mount the 14-pin IC firmly on the breadboard. Use the circuit diagram for reference. Connect linking wires from the power supply to the breadboard. Next, connect 14th pin of the IC to the plus 5-volt power supply. Then make sure pin 7 is connected with the ground. Moving on to the inputs, connect both terminals of the toggle switches to the power source and ground. And connect switches S1 to second pin and S2 to the third pin of the NOR gate as input. The output obtained from pin number 1 is fed to the 5th and 6th pin of IC as input, and the final output is obtained from pin number 4. Connect a resistor to the output pin of the IC. Attach the LED as well. With everything checked, switch on the 5-volt DC supply. Begin the test by operating switches S1 and S2. Check if the toggle switches S1 and S2 are in the low state. This indicates 0-0 combination. For this, let us verify the LED. It is not glowing. Now toggle the switches to 0-1 combination. Verify the LED. You may observe now that at the output, LED is glowing. So we know that if any of the input is 1 or both are 1, OR gate produces the output 1. Now toggle the switches to 1-0 combination. There is no change in the output state. LED is glowing. Finally, toggle the switches to 1-1 combination. There also, there is no change in the output state. LED is glowing. Finally, let us view the construction and testing of the NOT gate using NOR gate IC 7402 and verification of its truth table. Let's look at the logical circuit. Connect input A directly to NOR gate. A NOR gate inverts the input signal, acting as a NOT gate. Let us now look at the procedure. Collect all the required components and ensure the resistor and LED are in working condition using a multimeter. Once ready, mount the 14-pin IC firmly on the breadboard. Connect linking wires from the power supply to the breadboard. Next, connect 14th pin of the IC to the plus 5-volt power supply. Then make sure pin 7 is connected with ground. Moving on to the inputs. Connect both terminals of the toggle switches to the power source and ground. And connect switch S1 to the second and third pin as input A. Output is taken from the first pin of 7402 IC. Do not forget to connect IC output to an LED with a resistor. With everything checked, switch on the 5-volt DC supply. Begin the test by operating switch S1. Check if the toggle switch S1 is in the low state, that means 0. The output turns to 1. That means LED is glowing. If the toggle switch S1 is in high state, that means 1, the output turns to 0. That means the LED is not glowing.
This brings us to the end of this session. In this session, we have learnt how to construct AND, OR and NOT gates using NOR gate IC and realization of AND, OR and NOT gates using NOR gate and verify with their truth tables. Thank you for watching. We will see you in the next session.